Hello class, this is another video review for chapter 3, and in this video we are going to summarize what we have learned about solving non-homogeneous equations. Remember, a homogeneous equation is one where there is a y in every term. So a non-homogeneous equation will have at least one term where there is no y, and you have this fx over here. And the non-homogeneous term is typically always written on the right side. So if there's a 0 on the right, it's typically homogeneous. If there's an fx on the right, it's typically non-homogeneous. So you have this one term that has no y in it. So the way to solve to find the general solution of these problems actually is related to solving homogeneous equations as well. So we actually have to solve the homogeneous equation first to find the general solution. We first introduce YC, which is known as the complementary solution. YC is the general solution of the homogeneous equation, and it's typically written as C1y1 plus C2y. So the homogeneous equation simply means that you remove the non-homogeneous part, remove the fx, and this YC is the general solution of that equation. And you already know how to find the general solution. It's just the regular techniques we've learned. We also have to consider yp, which is a particular solution of the non-homogeneous equation. So this is just a single function, there's no constants in it. And we have, yp double prime plus pyp prime plus qyp equals fx. So this is just a single solution. To find the general solution of the non-homogeneous equation, it's still a second order equation, so we still need to have two constants. So the yp doesn't have any constants, but the yc does. And so to find the general solution, we have to add yc and yp. And you notice that if you add everything vertically in this way, if we add the equation in pink and the equation in orange together, we have yc double prime plus yp double prime plus pyc prime plus pyp prime plus qyc plus qyp equals fx. But this can be easily rearranged to this form. So we know that y equals yc plus yp is a solution to the non-homogeneous equation. And we know that yc plus yp has the two constants we need, simply because yc has the two constants, c1 plus c2. And this is our general solution. So to reiterate, to find the general solution of a non-homogeneous equation, you first have to find the general solution of the homogeneous part and add a single solution of the non-homogeneous part. And it's really all there is to it. So to find that single solution yp, we have two ways to do it, either by undetermined coefficients or by the VOP, the variation of parameters formula. And rather than explain it to you, I'm going to just link you to the videos we've done before. I think these things are best learned through examples.